day everyone, I am Imee Praile and I am here to present the paper titled Morphology, Internal Architecture, Facies Model and Emplacement Mechanisms of Lava Flows from the Central Atlantic Magmatic Province or CAMP of the Hartford and Deerfield Basins in USA by Moumou et al. On 2024. The Central Atlantic Magmatic Province, or CAMP, is described as one of the Earth's largest igneous provinces, formed around 201 million years ago during the initial breakup of the supercontinent Pangaea, which eventually led to the opening of the Central Atlantic Ocean. CAMP is represented today by both intrusive and extrusive remnants found across now separated regions of North and South America, northwestern Africa, and southwestern Europe. The estimated original extent of CAMP exceeds 7 million square kilometer with a magma volume of 2 to 4 million cubic kilometer, though its precise boundaries, especially in Africa and South America, remain uncertain. CAMP rocks are tholetic low titanium continental flat basalts with high titanium varieties restricted to specific areas. The origin of CAMP is debated, with hypotheses including a mantle superplum or lithospheric extension and thinning. The magmatism coincide with a Triassic-Jurassic mass extinction event. In eastern North America, CAMP volcanic rocks are found in several reef basins of the Newark supergroup, including the Hartford and Deerfield basins. The Hartford basins contain three main basaltic units such as Talcott, Holyoke, and Hampden, while the Deerfield basin has a single basalt formation, which is the Deerfield basalt, and despite extensive petrological and geochemical studies, the physical volcanology and emplacement mechanisms of these lava flows in the USA has been less explored. The Hartford, Deerfield, and related early Mesozoic continental reef basins that are preserved on the margins of the Atlantic bordering continents were formed during the incipient breakup of Pangaea in the Triassic. The overall structure of the Hartford basins, as shown in the figure in the portion B, is consistent with a step-faulted half-graben geometry as seen in other Newark supergroup basins. The Hartford Basin runs nearly north to south with a segmented west-dipping border fault system on its eastern side, toward which the basin strata tilt at predominantly low to moderate, with approximately 10 to 15-degree dips. The border fault system generally parallels the structural fabric of the Paleozoic metamorphic basement. It suggests that the border faults may be reactivated structures. The large-scale lithostratigraphy of the basin field is composed of tripartite succession as shown in portion C. The lower course Arcos unit that is up to 3,000 meter thick named the New Haven Formation. This is a middle that generally finer grain 2,500 meter thick sequence containing interbedded basalt flows of the CAMP near its base, which consists of the Talcott basalt, Shuttle Meadow Formation, Holyoke basalt, East Berlin Formation, Hampden basalt, and about the Lower Portland Formation, and an upper course Arcos until that exceeds 1,500 meter in thickness, comprising the Portland Formation. Based on their surface morphology and structure, basaltic lava flows were subdivided into pillow, pahoho, and aa flows. The pahoho flows are characterized by smooth and rocky surface and exhibit a typical three-tiered structures comprising a basal lava crust, a lava core, and an upper lava crust. The AA flows are characterized by a massive or prismatically jointed core enveloped by angular clinker at both the top and base. A wide range of intermediate flow types occurs between these two end member types such as Rabli Pahoho and Isla Pahoho. The products of an effusive eruption can be subdivided into three hierarchy levels: the flow lobes, lava flows, and lava flow fields. A flow lobe is an individual unit of lava enclosed in a chilled crust varying in length from decimeters to several kilometers and up to tens of meters in thickness. The lobes can be classified into two types: the S-type or the spongy lobes, vesicular throughout their thickness and lacking pipe vesicles, and P-type lobes, which is the pipe amygdale bearing that is characterized by pipe vesicles and vesicular base and top. The the lava flow is a regional subunit formed during a continuous effusive event, and if a lava flow consists of a single flow lobe, it is referred to as a simple lava flow. If the lobe has a sheet-like or tabular geometry, it is classified as a sheet lobe, and if the lava flow is composed of multiple lobes, it is termed compound lava flow. A lava flow is a field in a complex body consisting of several lava flows produced by a single eruption. Several sections were investigated from south to north across the basaltic formations cropping out in the Hartford and Deerfield basins in Connecticut and Massachusetts, and there are three principal basaltic formations occur in the northern Connecticut. First is the Talcott Basalt Formation. It is the oldest of the three flat basalts in the Hartford Basin. It is 50-meter thick volcanic sequence comprises five basaltic lava flow units, where the Unit 1 is composed of approximately 15 meter of closely packed large pillow lavas passing upward to smaller pillows within a hyaloclastite matrix. This figure shows the large, long rock cut behind the target store of Meriden, Connecticut, where in portion A, it is contact between the New Haven Formation and the first pillow flow of the Talcott Basalt Formation. The number 1 is a black mudstone, contorted with flame structure and isolated pillows, where the number 2 contact with number 3 are closely or densely packed pillow, and in portion B, it is the contact between the first pillow flow and the second sheet lobe flow of the Talcott basalt formation. The occurrence of the pipe vesicles in the basalt crust of the second sheet lobe and the preservation of the glassy zone and radial concentric cracks. And the portion C is the view of the flow units 3, 4, and 5 of the Talcott basalt formation. The flow unit 3 is composed of pillow breccias of 2 meter gradually overcome by a horizon of 1 meter with well-preserved isolated pillow and fragment pillow dispersed in a abundant hyaloclastite matrix which is covered by less than 1 meter of vesicular lava. The flow unit 4 is constituted by densely packed pillows, and it is compound in nature. And the last flow unit 5 is vesicular lava flow. And lastly, the portion D is the view of the flows unit 3, 4, and 5 of the Talcott basalt formations that is compound in nature of the flow units 3 and 4. The flow unit 4 is densely packed with pillow and emplaced by paleo channel. In portion A in this figure, it shows the fluidal peperites of the Neptunian dike of photograph of jigsaw fit class in basaltic breccia from the Neptunian dike. The portion B is a blacky pepperite of the Neptunian dike, where the blacky pepperite is formed in the background of the magma, producing brittle crackings. When hot magma intrudes cold water sediments, hot magma generates distortion and forms juvenile clast. The portion C is the Neptunian dike, or the clastic dike that cross-cutting the Talcott basalt formation at about 3 km ESE of the quarry of Tilcon, Connecticut, or North Branford on Fox Road. This basalt breccia filled fissures with an arcosic matrix and peperites, both the blacky and fluidal peperites are present, shows a chilled margin and injected arcos packet with the Talcott basalt. The blacky peperites and mixed blacky and fluidal peperites formed where rising melt interacted exclusively with groundwater and with coarse, water-saturated sediments of the New Haven Formation and underwent brittle fragmentation. The portion D is the fluidal peperites in the contact of the Hampden basalt with the East Berlin FM near Berlin along the RT9 South, and the portion E is the detail of the well-developed layers of blackish spicule layers or the accretionary lapilli, and lastly the F is the well-developed layers of blackish schirrule layers or the accretionary lapilli that might represent basaltic lapilli occur a few centimeter below the first pillowed flow of the Talcott basalt formation located in the large or long rock cut behind the target store in Meriden, Connecticut. The Holyoke Basalt Formation is 50 to 200 meter thick. The Holyoke Basalt can be traced almost continuously in a north to south direction for 160 km, but its east to west extent is uncertain and it must have been at least 50 km. The figure shows a panoramic view of the Holyoke flat basalt flow in the North Branford Quarry, Connecticut, and the capspate boundary or the dash line separate the radiating joints in entablature from vertical columnar joints in the colonnade of the Holyoke flat basalt flow. The boundary is approximately 100 meter above the base of this 200 meter thick section through the flow. The centers of the two cups is 15 meter apart. In the portion A, the two flows of the Holyoke basalt in the Tom Holyoke Mountains Quarry, Massachusetts, and in the portion B and C is the vesicle cylinder of the lava core of the Holyoke flat basalt flow in the North Branford Quarry, Connecticut, and in portion D, it is the fault or squeeze up and 30 to 40, 75 to 85 southwest, affecting the first flow of the Holyoke basalt in the Tom Holyoke Mountains Quarry, Massachusetts, and in portion it is the segregation sheets of coarse-grained ferrodiorite of the Holyoke flat basalts flow in North Brandon Quarry, Connecticut. The Hampden basalt is the thinnest extrusive unit in the Hartford Basin. It is typically massive and ranges in thickness from about 20 to 30 meter. It occurs between the East Berlin and Portland Formation. This is the horizontal vesicular zone of Hampden basalt at the section of the Rock Ridge Park, Hartford, Connecticut. The C portion is the contact of the Hampden basalt with the East Berlin FM near Berlin along the RT9 South, and the portion D is the contact of the Hampden basalt with the East Berlin FM near Berlin along the RT9 South with pipe vesicles, and the portion E is the ash bed or the Pompton tuff bed of the East Berlin FM with orange color near Berlin along the RT9 South, Connecticut. The portion G is the flow-top breccia of Hampden basalt at the section of the Rock Ridge Park, Hartford, Connecticut, and the portion F is the detail of flow-top breccia of Hampden basalt at the section of the Rock Ridge Park, Hartford, Connecticut. And for the discussion of the paper, the volcanic sequences in the Hartford and Deerfield basins were in place in tectonic basins with temporary lakes and sandy sediments. Early Talcott and Deerfield basalt flows form pillow lavas indicating underwater lava deposition within sediments. Later, Talcott flows become subaerial, showing the lakes had dried, but subsequent pillow lava suggests the basin was later flooded again. The Holyoke basalt formed a thick, inflated pahoho flow in a subaerial environment atop playa, lake sediments, with no pillow lavas present. The youngest Hampden basalt flows also erupted subaerially onto soft sediments. Chemically distinct Talcott, Holyoke, and Hampden basalt represent three separate lava flow fields fed by different dikes, showing a westward progression of magmatic activity. The Deerfield basalt correlates chemically with Holyoke basalt but erupted under deeper lake conditions. The Peperitic and Neptunian dikes, formed by explosive magma-water interaction and brittle magma fragmentation, are common and indicate complex magma-sediment interactions during eruption onset. These features help reconstruct local stress states and depositional environments during flood basalt emplacement. The camp volcanic sequence in the Hartford Basin formed through three volcanic pulses represented by the Talcott, Holyoke, and Hampden basalt units, while the adjacent Deerfield Basin records a single pulse. The Deerfield basalt chemically similar to the Holyoke unit. The volcanism occurred in both subaqueous and subaerial settings. The Talcott and Deerfield flow shows evidence of underwater and subaerial eruptions, whereas the Holyoke and Hampden were exclusively subaerial. The contacts between the flow units and underlying sediments often features peperites that indicate emplacement onto the soap sediments. The lava flows are dominantly basaltic with no intermediate or acidic lavas except some compositional segregation of Holyoke basalt. The eruption produced mostly simple pahoho flows and were fed by fissure eruptions along specific dikes rather than central vents. The volcanic activity took place in an extensional continental rift setting. Features such as squeeze-ups and breccia suggests complex lava flow dynamics. Overall, the volcanic succession fits the model of continental basaltic flood lava deposits. And for the conclusion, Hartford or the Central Connecticut and Deerfield or the Massachusetts basins are the northernmost onshore Mesozoic rift basins on the U.S. East Coast, and these basins contain CAMP or the Central Atlantic Magmatic Province, volcanic sequences important for understanding tectonic, sedimentary, and volcanic interaction. The the Hartford Basin features Talcott, Holyoke, and Hampden basalt formations, and the Deerfield Basin contains the Deerfield basalt. All basalts are chemically and mineralogically and structurally distinct despite being basaltic, and they represent three distinct lava flow fields with varying depositional environments from subaqueous to subaerial. The subaqueous units indicate underwater extrusion or lava entering lakes, and the Holyoke basalt or the Tilcon quarry is the thickest subaerial sheet lobe in USA Camp, which is approximately 200 meter, interpreted as a lava lake field. The Hampden formations, the 25 to 35 meter, consists of two subaerial sheet lobes and is the youngest unit. The Deerfield basalt, which is up to 75 meter, has two flows, the pillow lava and a subaerial sheet lobe, and geochemically similar to Holyoke. The subaerial flow shows inflation features, the pipe vesicles, vesicle sheets, cylinders, amygdales, and megavesicles. The typical sheet lobes have basal crust, massive core, and upper crust. And the Holyoke basalt took 136 years to solidify, and the other basalt cooled in months. The thicker flows develop pegmatite phases. The volcanic passages, slow, sustained eruption episodes consist with continental basaltic phases models. The dominance of simple pahoho flows, absence the intermediate or the acidic lavas, and the presence of peperites and vesicular structures indicates magma sediment interaction and variable cooling influenced by flow thickness and environment.